So now we start talking about interpreting or reading our graphs. And as I said at the end of the last video clip, this is true for all graphs. We talk about it specific to these population graphs, but all graphs, you can basically read them the same way. So there's three characteristics. There's three things that you can try to evaluate or to look for when you're trying to understand these graphs. And the first thing that you can look for is what's called central tendency. All of chapter 3 is about central tendency. So we get a little introduction to it right now. Central tendency simply asks, where is most of the data located? What's the center of where the scores are? Where do they tend to cluster up? So here on the top left, the curve like I had before, and we can see that most of the scores are in that zone, kind of in the middle. Over here, we can see it's off-centered. Most of the scores are down here low. There's a few scores way up here that are high scores, but the central tendency is off to the left-hand side. And here, this is one that has two central tendencies. We've got two gatherings or clusterings of scores here. We've got this lower cluster of scores, and we've got this higher cluster of scores. This is what a lot of class grades look like. There tends to be a pocket of folks not doing so hot and a pocket of folks really kicking butt in just about any class, not just this one. So, but that's just one thing to look for. You can look at the graph and simply say, well, how did most people score? What type of score did most people tend to have? And that's central tendency. The next characteristic is called variability. That will be, all of chapter 4 will be about variability. If we're looking at the variability of our data, what we're asking about is, are the scores very similar to each other or very different from each other? So differences is one of the common things one of the big words of the semester. When you hear variability, we're really asking about differences. Is my score different than your score, and how different? And are our scores different from that person's score, and how different? So are our scores pretty similar, or are they pretty diverse? That's another way I think of it, is diversity. Is there a wide diversity of scores in my data, or are they all kind of the same scores? Another way to think of variability is distance. So we can think of it as differences, or we can think of it as differences. How far apart are the scores? I've got a score of 2, you've got a score of 10. How far apart? I've got a score of 2, you've got a score of 100. How far apart? So how different are they, or how far apart are they, or how much diversity is there? So you can see that in your graphs. If we had a curve that looked like this, compared to a curve that looks like this, which one is showing us more variability? Which one is showing us a wider range of scores? This one on the left has higher variability than the one on the right. Literally, the scores are that far apart compared to that far apart. So it's simply a matter of, again, we're just eyeballing it off of this. In chapter 4, we'll have all kinds of math to calculate these ideas. But all we're looking for here is just getting a sense of the data. Did most people score the same as everyone else, or were people scoring all over the place? So that's the second characteristic. Third characteristic is called shape. And I alluded to that in an earlier video segment. We're going to be concerned primarily with 3 different shapes in this course. The first is what we call the normal shape. A normal shape has 2 characteristics. Most of the scores, the central tendency, will be in the middle of the data. And secondly, the curve will be symmetrical. So most of the scores are in the middle, not off on the left, not off on the right, or split up in some other way. And if we kind of look at it as a mirror image, It's more or less symmetrical. It doesn't have to be exact, but more or less. So that would be normal. So a curve can be symmetrical. That one that I drew with that looked like a camelback, 2 humps in the previous video, that was symmetrical, but it wasn't normal because it didn't have one lump in the middle. The other shape is skewed. The word skewed means off-centered. When we're saying something is skewed, we're saying that it is lopsided. It's not centered. And so both of these are lopsided. This one has a central tendency on the right side, and this one has a central tendency on the left side. So they're lumped up on one side or the other side. A lot of naturally occurring conditions are normally distributed. Intelligence is normally distributed. Height is normally distributed. I've read that the width of the stripes on zebras are normally distributed. Some are wider, some are thinner, but when you chart it out, this is how it looks. A few really wide stripes, a few really thin stripes, but most of them are in this central zone here. Skewed happens when you have an extreme score or an outlier. So an extreme score is a score that simply is not like the other scores. It's extremely different than. And so what we would have here in this skewed distribution, if we didn't have this extreme score outlier in it, it might have turned out to look, maybe like that, kind of normal. But what happened was we got one or more people with some really extreme scores that are unlike everybody else. And so it stretched that thing off balance to the left. If we were looking at, say, income in any nation, the United States would be no exception, we would be positively skewed. Most of us are down here. Can't make any less than 0. But you do have your, Bezos and all the other multi-godzillionaires out there, Elon Musk and all those other guys. But there's not many of them. There's a few of the super rich out there. So it pulls that graph off-center to the right. So this one on the left would be called negatively skewed because the rare scores, the extreme scores, are lower than the rest. The other way I sometimes say that is you can know that it's negative because if you turn this into an arrow where the tail is pointing, we call this the tail of the distribution, tail, 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 it's pointing towards where negative numbers live on a number line. So if the tail is pointing towards negative numbers, or if you say that the extreme scores are the low ones, it's negatively skewed. Over here, this is positively skewed, that the rare scores, the extreme scores, are these ones that are higher than all the others. And also the tail points towards greater and greater values, so it is positively skewed. So again, you can get a sense whether the shape is normal, positively skewed, or negatively skewed just from looking at the shape. And again, you can do this with bar graphs or histograms or any of that stuff. Same interpretation. So those are the 3 ways to, 3 things you can interpret out of a frequency distribution graph. So with that in place, this chapter is complete. So go back through your book, take some more notes. Take a look at the lab questions, work on those, work on more than those, but work on the lab things, check the video for the answers. Let me know if you need any help, if you have any questions. Of course, I'm always happy to try to help you out with that. All right, so chapter 2 is in the bag. We will see you for the next set of videos for chapter 3.